Modern life can make it difficult to picture what our ancient forebears experienced. Today, most of us have access to shelter, steady supplies of food, safe drinking water, and advanced medicine. Yet if we travel back in time just a few thousand years, the world becomes unrecognizable. The deeper we go, the more hostile and alien it seems. Early humans often lacked permanent shelter, wore primitive clothing, if any, hunted with stone-tipped spears, and relied on communal living for survival. Danger lurked around every corner. Mega predators like saber-toothed cats, enormous hyenas, and giant crocodiles prowled the same rivers and plains our ancestors depended on for food. To grasp the scale of these challenges, we need to journey across different eras, from the earliest hominins to more recent prehistoric humans like the Neanderthals, uncovering the obstacles they faced each step of the way. First, let's clarify what we mean by prehistoric humans. Prehistory refers to the span of time before written records existed. That means we rely on fossils, artifacts, and archaeological findings rather than historical documents to understand these ancient populations. Prehistoric humans, then, are our ancestors and close evolutionary relatives who lived before the advent of writing, including species in our broader Homo genus, as well as certain earlier hominins. These groups represent a branching family tree where some lineages died out entirely, while others contributed DNA that eventually shaped modern Homo sapiens. As we go along, you'll meet species like Australopithecus, Homo habilis, Homo erectus, Homo heidelbergensis, Homo neanderthalensis, and more. Each of these had unique adaptations, different body structures, brain sizes, diets, and survival strategies. Learning about them is like assembling an immense puzzle of bones, tools, and environmental clues that reveal where we came from. To begin our story, we head back around 4 to 2 million years ago, when members of the genus Australopithecus roamed eastern and southern Africa. These early hominins are not humans in the modern sense, but they represent a crucial step in our evolutionary tale. Standing upright on two legs, bipedalism, was their hallmark. While they retained some ape-like traits, such as relatively small brains and a strong reliance on climbing ability, they were already starting to look more human than chimpanzee. Fossils like Lucy, Australopithecus afarensis, discovered in Ethiopia, demonstrate their blend of primitive and advanced features. Their world was one of shifting climates and predatory threats from large cats, giant hyenas, and crocodiles. Living in small communities, Australopithecus likely survived by foraging, scavenging, and occasional group defense. They didn't yet have the complex tools or fire use that appear in later species, so life was extremely precarious. Around 2.4 to 1.4 million years ago, we see the emergence of Homo habilis, sometimes called handyman, for its association with stone tools. Fossil evidence suggests they possess slightly larger brains than their Australopithecus predecessors, and their hands were better adapted for precision gripping. This was a pivotal moment in prehistory. The ability to create and use simple stone tools, like sharp flakes for cutting meat, offered new survival strategies. Though Homo habilis was still relatively small and not as strong as many predators, the mental leap of tool use helped them scavenge and process animal carcasses more efficiently. Their environment, predominantly in eastern and southern Africa, remained rife with enormous threats, including saber-toothed cats. And yet, it was also a land of opportunity, as diverse ecosystems allowed for plants, fruits, and meat. This wider dietary range proved vital for fueling a slowly but steadily growing brain. Despite the advantage of primitive tools, Homo habilis faced an unforgiving world. Fossil evidence shows shockingly high mortality rates. Some estimates suggest the average life expectancy might have been as low as the early teens. Deadly diseases, parasites, and injuries with no modern medicine meant many children never reached adulthood. Predators were everywhere. Large cats like Meganterion or ancient hyenas could easily overpower these small hominins. Even a basic injury could become fatal, as open wounds led to infections. With limited height, often well under 5 feet tall, and modest body mass, Homo habilis had to rely on group living, sharp-eyed vigilance, and strategic use of trees for nighttime refuge. Still, they persisted for hundreds of thousands of years, incrementally honing the art of tool-making. Their legacy demonstrates that even slight boosts in brain power and dexterity could tip the balance between survival and extinction, an important lesson for us today. Perhaps no other early human species changed our evolutionary path as dramatically as Homo erectus. Emerging around 2 million years ago, Homo erectus had a larger brain than Homo habilis, a more modern body proportion, and a remarkable ability to travel. They spread from Africa into parts of Asia and Europe, adapting to climates that were drastically different from the tropical savannas of their birthplace. Often credited with harnessing fire, though the exact timeline is debated, these pioneering humans gained significant advantages. Cooked food is easier to digest, enabling more nutritional benefits. Fire also offers protection from nocturnal predators and a gathering point for social interaction. Homo erectus is associated with more advanced stone tools, sometimes grouped under the Acheulean tradition, which included hand axes that were symmetrical and carefully crafted. This leap in technology and resourcefulness marks them as a major milestone in the human story. Physically, Homo erectus looked more human-like, taller, with longer legs and shorter arms compared to earlier species. This meant they could walk and possibly even run over long distances, helping them chase down prey or migrate across vast territories. Brain capacity also increased, typically ranging from 700 to 200 cubic centimeters, still smaller than modern humans, but a substantial jump from Homo habilis. With these enhanced brains, they could coordinate group hunts, develop varied stone tools, and potentially engage in rudimentary planning or social rituals. They also faced a dynamic environment. Earth's climate during the Pleistocene was fickle, swinging between glacial and interglacial periods. Homo erectus had to manage temperature extremes from scalding heat to freezing cold. Large predators also roamed the same landscapes: giant hyenas, saber-toothed felines, and even enormous elephants or rhinos. The success of Homo erectus in so many settings is evidence of their adaptability and resilience. One of the most fascinating aspects of Homo erectus is their expansion out of Africa, a grand migration that predated the later, more famous migrations of our own species, Homo sapiens. Fossils in places like Denisovans in the Republic of Georgia and later sites in China and Southeast Asia show that Homo erectus ventured thousands of miles to occupy new habitats. In doing so, they encountered unfamiliar predators, giant Asian bears, saber-toothed cats like Homotherium, and massive crocodilians. They also had to adapt to different plant life, new seasons, and possibly higher latitudes with colder climates. These journeys weren't casual strolls. They were likely spread out over many generations, with small groups gradually pushing into new regions in search of food and safety. Some populations of Homo erectus eventually gave rise to distinct local groups, each shaped by its environment, a process we see repeated in later human expansions. Fast forward to around 700,000 to 300,000 years ago, and you'll meet Homo heidelbergensis. Many researchers consider them a transitional species between Homo erectus and later forms such as Neanderthals and modern humans. They had even bigger brains and more sophisticated behavior, like evidence of organized hunting of large game. Their stone tools were advanced, featuring refined hand axes and flake tools. Fossil findings from sites in Europe and Africa show how they might have used wooden spears to take down large animals. In Europe, Homo heidelbergensis populations encountered harsh Ice Age conditions, shaping them into what would eventually become Neanderthals. Meanwhile, African populations may have been the precursors to anatomically modern humans. The environment continued to test them. Massive cave bears, giant elk, and dire wolves were formidable threats. But their robust build, refined group cooperation, and advanced technology made Homo heidelbergensis stand out among earlier relatives. Often misunderstood, the Neanderthals, Homo neanderthalensis, roamed Europe and parts of Western Asia between roughly 400,000 and 40,000 years ago. Stocky, muscular, and well adapted to colder climates, they're famous for their protruding brow ridges and large nasal cavities, which helped warm and humidify frigid air. Their brains were even larger on average than ours, although configured somewhat differently. This doesn't necessarily imply they were smarter in the same ways we are. Rather, they had distinct strengths, like excellent vision and robust physique. Neanderthals were skilled hunters of big game, woolly mammoths, giant deer, even cave bears. They used advanced stone tools known as Mysterian tools, carefully flaked and retouched. Once dismissed as primitive cave dwellers, modern evidence shows they had buried their dead, possibly used pigments for decoration, and crafted personal ornaments. In short, they were complex, adaptable, and surprisingly sophisticated ancient humans. If you could travel back in time to meet a Neanderthal, you'd likely be impressed by their sheer strength. Fossil analyses suggest they were built for power and close-quarters hunting, with thick bones, heavy musculature, and potentially high hormone levels that aided muscle growth. Their daily life revolved around cooperative hunts, likely ambushing megafauna at close range with thrusting spears. This physically demanding approach explains their frequent injuries. Broken bones were commonplace, and many skeletons show evidence of healed traumas, suggesting strong social support that allowed injured individuals to recover. Neanderthal communities likely numbered around a few dozen members, centered in caves or rocky shelters for protection. Their environment was often frigid. European glacial periods made survival a constant test. Nonetheless, they found ways to adapt. There's even evidence they utilized fire to stay warm and cook meat, which helped them extract maximum calories from their often protein-heavy diet. Around 200,000 to 300,000 years ago, early Homo sapiens began to appear in Africa. As they spread out, these new arrivals eventually crossed paths with Neanderthals in the Middle East and parts of Europe. Genetic studies now show that many non-African humans today carry a small percentage of Neanderthal DNA, clear evidence that these two human groups interbred. This genetic legacy affects certain traits in modern populations, though often subtly. We also see signs that Neanderthals may have learned or traded tools and techniques with Homo sapiens. Yet by around 40,000 years ago, Neanderthals vanished from the fossil record. Why they disappeared remains a topic of debate. Possibilities include climate fluctuations, competition with anatomically modern humans, or simply low population numbers leading to inbreeding and decline. Whatever the cause, their story serves as a reminder that multiple human species once coexisted, and that evolution does not promise survival to any one branch. The human story becomes more intricate when we consider the Denisovans, an archaic hominin group identified from scant fossil remains in Siberia's Denisova cave. Genetic analysis reveals they shared a common ancestor with Neanderthals, diverging into a separate lineage that spread across Asia. Like Neanderthals, they interbred with Homo sapiens, leaving genetic marks in modern populations, particularly in parts of Southeast Asia and Oceania. Similar discoveries hint at additional, still unknown branches of the human family tree. Every new fossil or genomic study adds layers to our understanding of how prehistoric humans spread, adapted, and sometimes merged. While we may never have a perfect picture of all these ancient relatives, the ongoing revelations emphasize that humanity was once a rich tapestry of interrelated species, each forging its own path amidst a world full of perils, ranging from treacherous landscapes to monstrous beasts. One of the most intriguing prehistoric human groups is Homo floresiensis, fondly nicknamed hobbits due to their small stature. Adults stood only about a meter, 3-4 feet tall. Discovered on the Indonesian island of Flores, they lived as recently as 50,000 years ago. Their tiny size may reflect island dwarfism, a phenomenon where limited resources and isolation favor smaller body types. Despite having brains roughly the size of a chimpanzee, H. floresiensis left behind stone tools that suggest notable intelligence and adaptability. They coexisted with unique island fauna, such as giant rats and mini-elephants called stegodonts. Yet they also encountered big threats in the form of colossal Komodo dragons and enormous storks. The existence of H. floresiensis expands our perspective, reminding us that human evolution isn't a simple straight line. Different environments can shape unexpected forms, each tested by nature's challenges in ways modern humans can scarcely imagine. We've mentioned saber-toothed cats and giant hyenas, but prehistoric humans also contended with an astonishing array of other deadly animals. Imagine crossing paths with a short-faced bear towering over modern grizzlies, or a running hyena capable of chasing you down with cheetah-like speed. Rivers and lakes teemed with gargantuan crocodiles that might snatch an unwary drinker from the shore. In cold northern realms, there were huge cave lions and the intimidating scimitar-toothed Homo. These predators evolved to hunt large, robust game, mammoths, giant buffalo, or even rhinoceroses, so a small band of humans with simple spears stood little chance in a direct confrontation. Ancient footprints and gnaw-marked fossils reveal that prehistoric humans sometimes ended up on the menu. Survival meant being vigilant, using teamwork, finding vantage points, and developing tools or strategies that gave at least a slight edge in these predator-dominated ecosystems. Beyond carnivores, climate was another relentless adversary. During the Pleistocene epoch, roughly 2.6 million to 11,700 years ago, Earth underwent repeated glacial cycles, sometimes locking vast areas under immense ice sheets. These periods forced human communities to migrate or adapt, seeking refuge in warmer latitudes or more sheltered landscapes. Then came interglacial phases, with warmer and sometimes wetter conditions that could transform open plains into lush forests and alter the availability of edible plants and game animals. A group living at the edge of a new glacier might starve if game migrated south. Conversely, they might flourish for a few centuries in a warmer spell, only to face catastrophic drought or resource shortages later. Over time, these cyclical changes forged resilient traits in prehistoric humans, better cooperation, improved tool-making, and more strategic planning for resources. We often credit modern humans with remarkable adaptability, but it began countless millennia earlier. Tools played a crucial role in how prehistoric humans coped with their harsh surroundings. The earliest known stone tool tradition, older one, often linked to Homo habilis, consisted mainly of simple flakes, choppers and scrapers, enough to extract marrow from scavenged bones or slice through tough animal hides. With Homo erectus, the Acheulean toolkit introduced advanced hand axes, teardrop-shaped, symmetrical implements used for chopping, cutting, and digging. Over time, more specialized techniques emerged, culminating in technologies like the Mysterian toolkit used by Neanderthals, which featured carefully prepared cores that produced standardized flakes. These leaps in tool design weren't mere technical feats, they reflected growing cognitive complexity. Crafting these implements required foresight, coordination, and the ability to visualize a finished shape in the raw stone. Tools also facilitated new diets, giving humans a better chance against monstrous predators by allowing them to scavenge and butcher large carcasses quickly. Fire was arguably the most transformative discovery. Evidence of controlled fire appears as early as 1 million years ago, perhaps with Homo erectus in Africa, though routine use may have come later. With fire, prehistoric humans could ward off predators at night, extend their daytime by gathering around the warmth after sundown, and cook meat, which kills parasites and makes proteins more digestible. Cooked foods likely contributed to increased brain size over generations by unlocking greater energy returns. Fire also served social and cultural functions. Gathered around the flames, groups could share stories or knowledge, an early form of collective learning that shaped cultural identity. Over time, charcoal, ash, and hearth remains become recurring features in archaeological sites, signaling that fire, once a fearsome natural element, had become an integral part of daily life, drastically improving survival odds in a perilous world. For prehistoric humans, cooperation wasn't just advantageous, it was essential. With so many formidable predators and constant threats, an individual alone stood little chance. Living in groups meant joint defense against lions or hyenas, more eyes to spot danger, and combined effort in hunting or gathering. Archaeological evidence, from communal hunting traps to the care of disabled individuals, reveals that these ancient communities looked after one another in ways beyond mere survival. For instance, fossil remains showing healed major injuries suggest that group members tended wounds, shared food, and helped each other recover. Such cooperation laid the foundation for more complex social behavior and cultural transmission. Skills in tool-making or knowledge of seasonal migrations could be taught, ensuring younger generations didn't start from scratch. This passing on of learning, amplified around the hearth, helped prehistoric humans refine their tactics. Making them more than just prey, they became formidable survivors in an unforgiving landscape. Though often imagined as purely carnivorous, prehistoric humans had varied diets tailored to the environment. Early hominins gathered fruits, nuts, and tubers. Species like Homo habilis and Homo erectus both hunted and scavenged, supplementing with plant foods. By the time of Neanderthals, specialized big-game hunting was common, especially in colder regions where plant resources were seasonally scarce. Cooked meat, thanks to fire, provided high-calorie meals that fueled their robust bodies and large brains. Still, many groups also relied on fish, shellfish, honey, eggs, insects, or whatever local resources were available. Archaeological findings of grinding stones hint that certain populations processed seeds and grains, suggesting an early form of culinary ingenuity. The advantage of dietary flexibility cannot be overstated. Having a broad menu allowed humans to survive dramatic climate shifts and environmental upheavals. Where a more specialized species might starve, prehistoric humans often found new ways to feed themselves. Even if one evaded predators, disease and parasites posed an invisible but lethal threat. Without modern sanitation or medicine, infections from minor wounds could become deadly. Water sources often teemed with pathogens, and close contact with animals introduced the risk of zoonotic diseases. Conditions like dysentery, malaria, and parasitic worms undermined strength and shortened lifespans. Fossilized bones sometimes display signs of chronic illness or abscesses, grim testimonies to how everyday life could become a constant battle against unseen enemies. Lifespans varied by species and time period, but many prehistoric humans likely died before reaching what we now consider adulthood. However, those who survived into their 30s or 40s might have been community elders, treasured for their experience. Caring for the ill or injured also strengthened social bonds, reinforcing that even primitive communities recognize the value of group welfare, despite a world that offered them few comforts and many dangers. Scientists studying modern DNA have discovered hints of ancient population bottlenecks, times when human numbers drastically shrank, possibly due to severe climate shifts or catastrophic events. One major bottleneck may have occurred around 900,000 years ago, with the global human population dropping to a perilously low level. Surviving groups had to contend with glacial conditions, dwindling food resources, and fierce competition from other predators. This near extinction likely shaped the genetic and cultural makeup of later human lineages, as only the most adaptable, cooperative, and resourceful groups pulled through. While hotly debated among researchers, some argue different timelines or triggers, the idea underscores how fragile human existence once was. Our ancestors lived at the mercy of disease, climate, and terrifying predators, with no guarantees. The fact that any of these early humans made it through says a lot about their resilience, a trait that clearly resonates in modern Homo sapiens. Eventually, Homo sapiens emerged in Africa, anywhere between 300,000 and 200,000 years ago, according to the latest fossil and genetic evidence. By around 100,000 years ago, some groups started leaving Africa, following routes into the Middle East, Europe, and Asia previously explored by Homo erectus and other species. These anatomically modern humans brought with them advanced stone blades, bone tools, and even early forms of symbolic expression, like shell beads and rock art. They encountered Neanderthals in Europe and Denisovans in Asia, occasionally interbreeding and exchanging cultural elements. With generally more gracile builds than Neanderthals, Homo sapiens nonetheless possessed a sophisticated capacity for innovation and complex language, allowing them to adapt to an astounding range of environments. Over the millennia, they would navigate ice-age tundras, dense rainforests, arid deserts, and eventually cross oceans to reach new lands. In their wake, older hominin species would vanish, leaving modern humans the sole survivors. One hallmark of Homo sapiens is the blossoming of symbolic thought, evidenced by cave paintings, carved figurines, and jewelry. Sites like Lascaux in France or Altamira in Spain stun us with detailed depictions of bison, horses, and mysterious symbols. These artworks hint at ritual or spiritual elements and a capacity for imagination beyond simple survival tasks. Such creativity was more than mere self-expression. It symbolized an ability to plan, communicate complex ideas, and form cultural identities that could unify large groups. This growing cognitive sophistication likely played a role in how modern humans organized hunts, developed trade networks, and built alliances. Over time, these cultural developments helped them outcompete other hominin lineages, who may not have matched the same level of cognitive and symbolic complexity. Cave art thus stands as a testament to a new phase in humanity, one where survival was guided not just by tools, but by shared stories and visions. As Homo sapiens advanced, so did their tools. Lithic technologies shifted from chunky hand axes to thin, standardized blades capable of greater efficiency. The use of bone, antler, and ivory to fashion harpoons, sewing needles, and composite tools broadened their subsistence strategies. This was crucial for hunting large animals, from reindeer and horses in ice-covered plains to buffalo in African savannas. They devised traps, sophisticated spears, and possibly early bows, though physical evidence for bows is scarce until later. Organized group hunts became more strategic, often involving coordinated drives of animals off cliffs or into natural enclosures. These methods reduced individual risk and maximized yields, feeding growing populations. Mastery of advanced tools and tactics gave Homo sapiens a decisive edge over other hominins. With broader diets and better adaptability, they could flourish even when megafauna populations fluctuated or climates worsened. It was evolution in action, fueling ongoing expansion. For prehistoric apex predators, the rise of Homo sapiens was a disruptive event. Giant cave lions, saber-toothed cats, dire wolves, and enormous bears had long dominated Pleistocene ecosystems. Suddenly, they faced a small but cunning primate that teamed up in groups, wielded projectiles, lit fires, and operated with cunning strategies that subverted the old rules of raw strength. Over centuries, humans gradually forced large carnivores to adapt, retreat, or face extinction. Their formidable advantages, powerful jaws, swift bursts of speed, grew less effective against a determined band of humans using coordinated attacks or weapons that could strike from a distance. Of course, it wasn't a quick or straightforward victory. Early humans still died in large numbers, and these predators remained a horrifying threat. But by the Upper Paleolithic, it was clear that Homo sapiens possessed a game-changing formula for success: technology plus social cooperation, backed by advanced cognitive skills. Around 26,000 to 19,000 years ago, the last glacial maximum brought some of the most severe cold conditions of the Ice Age. Continental ice sheets extended far south in the northern hemisphere, altering global weather patterns. Sea levels dropped, exposing land bridges like Beringia between Asia and North America. Human populations, especially in Europe, survived by finding refuge in milder southern regions or well-sheltered enclaves. Archaeological sites from this period show advanced tool traditions like the Aurignacian and Gravettian in Europe, featuring fine blades and decorative art. But even with these advancements, daily life was grueling. Imagine bleak, near-frozen landscapes where large mammals were harder to track and vegetation was sparse. Communities that endured relied on meticulous planning and resource management. In these harsh conditions, any misstep could be fatal. Yet, ironically, the ice also allowed migrations across newly exposed land corridors, seeding human expansion into lands previously unreachable. As the Ice Age tightened its grip, prehistoric humans developed specialized adaptations to cope with cold. They crafted warmer clothing from animal hides and furs, possibly stitching them with needles made of bone. They built sturdier shelters, perhaps mammoth bone huts in regions like Eastern Europe, or using natural caves when available. Artwork from this period hints at the significance of these large game animals, not only as food, but also as raw materials for survival. Groups likely followed migrating herds over vast distances, forging seasonal routes they memorized and passed on. Meanwhile, the capacity to store food, by drying, smoking, or freezing, helped communities bridge lean times. These innovations gave humans unprecedented flexibility, letting them thrive in regions that might have been lethal to earlier hominins. Over tens of thousands of years, these survival skills laid the groundwork for the global spread of Homo sapiens, culminating in permanent settlement on almost every continent. One of the most remarkable chapters in human prehistory involves the peopling of the Americas. While exact dates and routes remain debated, many researchers point to the Bering Land Bridge as a key passage when sea levels were significantly lower. Groups of hunter-gatherers ventured from Siberia into Alaska, eventually moving south into unoccupied territories teeming with large mammals, mammoths, mastodons, giant ground sloths, and powerful carnivores like the saber-toothed cat, Smilodon. Archaeological sites such as Monte Verde in Chile or sites in North America show complex stone technologies, including fluted projectile points like Clovis points. These tools likely aided in big game hunts. Yet, as in other regions, humans faced new challenges, adapting to unfamiliar flora and fauna, coping with diverse climates that ranged from icy tundra to tropical forests, and confronting predators unaccustomed to upright, tool-wielding primates. This wave of migration showcases humanity's thirst for exploration and unending resilience. From Africa's savannas to the frozen tundra of Eurasia, prehistoric humans overlapped with an astonishing variety of megafauna: woolly mammoths, giant elk, woolly rhinos, and more. Some hypothesize that human hunting played a role in driving many of these large animals to extinction. Others argue that rapid climate changes also stressed megafauna populations. Likely, the combined pressures of skilled human hunters and shifting habitats created a tipping point for species that struggled to reproduce quickly or adapt. Fossil evidence shows butcher marks on mammoth bones, and thousands of years later, mammoths vanished from many regions. The story isn't simplistic. Some megafauna persisted in isolated pockets, and some regions show little evidence of overhunting. But we can't ignore that the arrival of well-organized, technologically adept humans introduced a new predator dynamic that many large herbivores and carnivores weren't adapted to face. As the Ice Age began to wane, Homo sapiens populations grew. Around 40,000 to 10,000 years ago, often called the Upper Paleolithic, we see a surge in artistic and cultural achievements: cave paintings, bone flutes, Venus figurines, and intricate body adornments. Rituals and burial practices became more elaborate, hinting at complex belief systems. Communication likely improved through sophisticated languages, enabling the creation of mythologies, kinship networks, and broader social ties. Toolkits diversified further, including microliths, tiny, sharp stone segments mounted on shafts, forming composite arrows or spears. This period also marks the end for some competing human species. The Neanderthals and Denisovans fade away, leaving modern humans as the last standing hominin. Strong communal bonds, advanced technology, and symbolic culture appear to have been a winning formula, giving these late Paleolithic people an unprecedented capacity to adapt, innovate, and ultimately shape the planet's ecosystems. For many of the so-called monster predators, such as giant short-faced bears or massive saber-toothed cats, the end of the Ice Age spelled doom. As the glaciers retreated, ecosystems changed. Grasslands gave way to forests or vice versa, altering prey distributions. Coupled with rising human populations expanding into new territories, apex predators found themselves in shrinking habitats, outcompeted for resources. Some died out, while others, like the cave lion, lingered longer in remote regions. By the time the climate stabilized, much of the monstrous Pleistocene megafauna was gone. Their demise opened ecological niches for smaller carnivores, but it also changed the dynamic of human life. Without giant predators constantly lurking, survival challenges shifted. Humans could increasingly focus on stable communities, agriculture, or more specialized hunting strategies. Yet, it's worth remembering that in many corners of the world, from Africa to parts of Asia, big predators still roam, echoing that ancient peril. By roughly 12,000 to 10,000 years ago, certain groups began experimenting with planting seeds and domesticating wild plants, marking the dawn of agriculture in places like the Fertile Crescent. This was a game changer. Reliable food supplies encouraged permanent settlements, population growth, and more complex social structures. As humans cleared land for crops, they also reshaped landscapes, potentially driving out or reducing populations of large wildlife that once thrived there. Domesticated animals, like goats and sheep, reduced the need for dangerous hunts. Over generations, agricultural societies produced surpluses which supported craftspeople, traders, and the rise of technology. It's a far cry from the daily scramble for survival that characterized most of prehistory. While this shift didn't happen overnight, and some hunter-gatherer groups continued thriving for millennia, agriculture marked the close of the Paleolithic era and ushered in a new age, the Neolithic, where humans increasingly shaped the environment to suit their needs. It's astonishing to consider all the challenges prehistoric humans faced. They endured repeated ice ages, scorching droughts, massive volcanic eruptions, and competition from apex predators that dwarfed anything we typically encounter today. They survived disease without antibiotics, injuries without hospitals, hunger without guaranteed meals, and predatory threats without modern weapons. Yet they persisted, innovating step by step, from the first crude stone flakes to finely crafted blades, from fearsome nights without fire to warm communal hearths. Each prehistoric species, whether Homo habilis, Homo erectus, or the mighty Neanderthals, made contributions to the tapestry of human adaptation. Though many lineages fell extinct, they left behind lessons embedded in our DNA and our cultural memory. Their story isn't just a dry account of bones and artifacts. It's a testament to a resilience and curiosity that define our lineage, a drive to explore, learn and survive in the face of overwhelming odds. The study of prehistoric humans is far from complete. Every year, archaeologists uncover new fossils, artifacts, or genetic evidence that can rewrite entire chapters of our evolutionary history. Ancient DNA analyses have revealed previously unknown hominin groups and shown how interwoven our family tree really is. Meanwhile, advanced dating techniques push the timeline of major events, like when fire was first harnessed, further back. Debates rage on. Did Homo sapiens outcompete Neanderthals primarily because of superior cognition, or was it a combination of climate advantage and luck? Did other species like Homo floresiensis persist longer than we think on remote islands? Each discovery adjusts our perspective. While we once saw a linear progression from ape-like ancestors to modern humans, it's now clear that human evolution is more of a branching bush, with repeated experiments, dead ends, and occasional hybridization. This complexity makes the story of prehistoric humans all the more captivating. Some might wonder, why should we care about these ancient humans? After all, we live in a world of towering skyscrapers, instant communication, and medical miracles. But our deep past carries vital lessons. It shows that human resilience is rooted in cooperation, innovation, and adaptability, traits that let us endure drastic climate changes and environmental challenges. Studying prehistoric extinctions also warns us of the delicate balance ecosystems require. Through overhunting or habitat destruction, we once contributed to the disappearance of megafauna. Now, we face modern equivalents in the form of endangered species and global climate shifts. Understanding how earlier human species lived and died underscores our shared heritage and mutual vulnerabilities. In these ancient stories, we can find both cautionary tales and sources of inspiration, reminding us that we're part of a grand continuum, and our actions today echo far into the future. It's easy to reduce prehistoric humans to caricatures, stooped figures grunting around a campfire, or savage hunters swinging clubs in a primeval wilderness. Yet the evidence reveals a people capable of empathy, artistry, and ingenuity. Neanderthals cared for injured peers and created symbolic ornaments. Early modern humans adorned cave walls with emotive artworks, conjuring spiritual or cultural narratives. Homo erectus traveled vast distances in small groups, forging novel solutions wherever they went. Each species lived under stark conditions with almost no safety net, yet they found ways to thrive. We also shouldn't overlook their emotional lives. They formed familial bonds, grieved their dead, and shared laughter around communal fires. Although we lack direct testimony of their thoughts, the traces they left speak volumes about perseverance and hope. Reimagining them as whole people fosters a deeper appreciation of our shared past, and a sense of humility about our place in history. Yes, we have technology and global networks that would seem miraculous to a Neanderthal or an early Homo erectus. Yet the seeds of cooperation, tool use, and creativity were sown deep in our evolutionary past. We owe our upright posture, nimble hands, and large brains to the successes and failures of countless generations of prehistoric humans. Their footprints, left in mud and volcanic ash, paved the way for our footprints on the moon. The sense of wonder we feel gazing at cave paintings links us directly to the awe they once felt under starlit skies. Our shared ancestry is both humbling and empowering, reminding us that no matter how sophisticated our present becomes, the lessons of adaptation, community, and respect for nature remain as relevant as ever. We've seen how different species of prehistoric humans, from Australopithecus to Neanderthals to Homo sapiens, navigated landscapes that were as breathtaking as they were perilous. Each era brought its monsters, mighty saber-toothed cats, towering bears, relentless hyenas, and each era shaped our ancestors in unique ways, forging stronger social bonds, sharper minds, and deeper cultural expressions. It's a story of survival against all odds, achieved through innovation, cooperation, and an unyielding drive to explore new frontiers. As you go back to your modern routines, spare a moment to think of how far we've come. Every technological marvel, every piece of art, every social structure we cherish today stands on foundations built in the distant past.